Today we want to do equations. Equations is a very crucial things or crucial things in mathematics. So what is an equation? An equation is a mathematical sentence. It is a mathematical sentence, right? Which could be true or false. So we are saying an equation, a mathematical sentence that true, it can be false, right? So it has an unknown. It has an unknown. An equation is an unknown. So that's something that you have to know, right, in its end, right? So its truth, right? The truth of the equation depends now on the value of the unknown. So we are saying the truth of the equation, it depends on the value of the unknown. For example, we can say x plus 2 is equals to 3, right? We say it false for all values of x except when x is equals to 1. So all other values. So we are saying if x is equals to 1, if we say x is equals to 1, it is true, right? Because x plus 2 is equals to 3. So we say the solution of the equation is x is equals to 1. That is the solution. So we are saying what is the solution or root of an equation? Because you would see, like you asked, what is the solution of this equation, right? So we are saying the solution or a root of an equation is the value, the solution or the root of the equation, the value of x that makes the equation true, right? That is what the solution of the equation is, the value of x that makes the equation true, right? So for example, in lower grades they will give you a box. It's an unknown plus 2 is equals to 3, right? And then you say what plus 2 is equals to 3. The answer is 1, right? And that 1 is the root. So that's how we can actually introduce equations, right? So we are now want to do what does now solve for x means, because you could actually see that you get questions like solve this equation. So what does solve for x means, right? So we can say to solve, right? When we are saying we are to solve, right, it means you have to respond, right? You have to look for the what? For the solution or the root. So to solve is to look for the solution or root. That is the solve. So all the equations should be checked, right? All the equations should be checked. You can also solve by inspection, right? So again, you can solve linear equations. When we are speaking of linear equations, these equations, they are in the form of y is equals to mx plus c. Again, you can solve for that, right? So for example, let's say we want to solve for, let's say 3x plus 1 is equals to 16, right? So your response is like you collect like terms. So we are saying with equations, what you do on the left side, you do it also on the right side. So we are saying 3x plus 1 minus 1 is equals to 16 minus 1. So the 1 plus 1 minus 1 is going to cancel. You are left with 3x is equals to 15. And then now you divide by 3, you divide by 3. This 3 cancels, so it's x is equals to 5. Right. So the solution is x is equals to 5, or the root of the equation is x is equals to what? To 5. Right. Or again, you can solve, let's solve this equation, x is equals to x plus 2. Right. Let's collect like terms. So we are saying x, right. Now we are saying if you want to look for the value of what? Of x. Right. If we subtract 2, so it means x is equals to x plus 2. Right. So you can say there is no solution on this equation. There is what? There is no solution in this equation. Right. And again, if we get an equation like 5x is equals to x, again, the response we can say now, we divide by 5, we divide by 5. So the solution x is equals to 0. Right. So that's how you solve that equation. And maybe you can get a question like 2 bracket x plus 3 is equals to 2x plus 6. So we are saying 2x plus 6 is equals to 2x plus 6. So here we are just saying this equation is just true. That is your response, because we are saying this side is equivalent to what? To the other side. So that's how you solve for linear equations, right? So it's very, very important to know what is actually happening, right? So again, you can solve equations using the mechanical method for solving equations. For example, if they are fractions, you multiply both sides by the what? By the LCD, right? That's the mechanical, right? Let's look for a problem like 2 bracket 2x minus 8 is equals to 1 over 7x. Right, so the first thing is to open your brackets. 4x plus 16 is equals to 1 over 7x. So from there, we are saying multiply out brackets to 3x, and then you shift terms by, right, all the terms, right, the x terms, they are supposed to go on one side, right? So we are saying 4x, and then if this 1 over 7, we are going to subtract it, or if it goes the other side, it's going to be minus 1 over 7, right, is equals to 10, right? And then we say 4 minus 1 over x is going to be 3, right? And 6 over 7x is equals to 10. And we divide the whole expression by 3 and 6 over 7, 3 and 6 over 7. So we'll get x is equals to 112 over 27, right? So this is how you solve the one that is having fractions, right? Or you can collect like terms and you divide by the what? By the coefficient, right? So again, in mathematics, you could actually see that there are 6 operations that are grouped in 3 pairs. We can talk of a positive and a negative, a times and a divide, and the power and the roots, right? So we are saying a positive and a negative, they are opposite operations, right? So if we take, for example, we are saying, let's think of that one that we said x plus 3 is equals to 5, right? So the first step is like we are subtracting 3 both sides, you see. So this 3 cancels, so we are left with x is equals to 2, right? So we are saying if we are taking 3 to the other side of the equation, it will change sign. That's the other faster way of doing it. So instead of like subtracting 3 both sides, just have to know that if this 3 goes to the other side, it's going to be 5 minus 3. It's going to change this sign, right? So that's one thing you have to know about when we are dealing with positive and negative signs, opposite operations, right? And if it was x minus 3 is equals to 5, it means if the 3 goes to the other side, it's going to be a 5 plus 3, and that's 8, right? And then we can also think of operations like times and divide. Let's think of an equation like 3x is equals to 6. 3x is equals to 6. If you want to solve this equation, what we do is like the opposite of multiplication is what? The opposite of multiplication is division. So we divide by 3, we divide by 3, so that we can make x the subject of the formula. So if we divide, this x is going to what? To cancel, so we are left with x is equals to 2. So that's how you also solve equations that is involving a number and a coefficient, right? They are together. It's 3x. It's not 3 plus x. So 3x, it means 3 times x, right? And then sometimes you can be asked to solve an equation that is having a powers or roots. For example, x to the power 3 is equals to 3. So if you want to solve this equation, you say the opposite of a cube is the cube root. So we said cube root of x to the power 3. This 3 is now going to cancel, and then the cube root of 8, you know it's what? Is 2. So the solution is x is equals to 2. So that's how we solve. Or maybe we can say x squared is equals to 25. So if you want to solve x, you say now the square root, because the opposite of square is what? Is the square root of 25, which is equals to 5. Again, you can get a question like x to the power 4 is equals to 16. If you want to solve this one, the opposite of the fourth root is what? The fourth cube of what? Right, of 16, right? So you will discover that it's going to be what? 2, right? And then again, we are saying if x cubed is equals to minus 8, let's say x cubed is equals to minus 8, it means x is equals to minus 2. And then if x cubed is equals to 8, it means what? X is equals to 2. So that's how you also solve the roots. So this is just the basic introduction to how you solve equations. So it's very, very important to understand how you solve equations.